Design and physicochemical evaluation of acetyl salicylic acid glycine co-crystals obtained by dry grinding with evaporative cocrystallization to enhance the solubility and dissolution profile of acetyl salicylic acid ASA, known for its anti-inflammatory activity and counteract pain. In this work describe the co-crystallization of ASA with glycine-GLY, an amino acid with antioxidant and anti-inflammatory activity, besides high solubility in water, expecting a synergistic effect on its properties. The ASA-GLY co-crystals were prepared using dry grinding with evaporative co-crystallization, determining that the milling time is an important factor to avoid drug hydrolysis, and were characterized by different techniques such as FTIR and Raman spectroscopy, powder X-ray diffraction (PXRD), differential scanning calorimetry (DSC), solid 13C MOS NMR, and dissolution test in pH 6.8 and 1.3. Approximately 90% of pharmaceutical products contain active substances in crystalline form, and about 92% of the drugs that are registered in the United States Pharmacopoeia have solubility and compactability problems. A co-crystal can be obtained from two compounds in a solid state, drug and conformer, and allow the modification of the physicochemical properties as the drug's solubility by commonly interactions of hydrogen bonds. Our goal is to obtain a co-crystal from aspirin, ASA, and glycine-GLY. From the technique of grinding with assisted liquid, the co-crystals obtained from ASA-GLY and ASA-GLY have a transparent acicular morphology, thick needle shape. Infrared spectroscopy analysis. The carbonyl signal corresponding to the drug is found at 1679 cm1, at amino acid 1682 cm1, and in the crystalline product 1609 cm1. Move to a shorter wavelength due to the modification of the nature of the double bond, weakening it by electron density movement between the carboxylic acid section of the drug and the amino group of the amino acid. Raman spectroscopy analysis. Raman shifts the vibrational bands corresponding to the carbonyls of both the drug and the amino acid can be identified in the two co-crystals obtained in the compound ASA-GLY 1-2. The carbonyl is located at 1633.6 and 1665.4 cm1, being the second corresponding to the amino acid and the first to salicylic acid due to the hydrolysis of the drug. And in the compound ASA-GLY 1-1 product at 1578.5, 1631.4, and 1642.2 cm1, indicating the presence of two carbonyls corresponding to the unhydrolyzed drug. The bands at 1578.5 and 1631.4 cm1 being those of the drug, and the one at 1642.2 cm1 those of the amino acid. Analysis. Changes in crystallinity observed in the sample ASA-GLY 1-2. The highest peak intense appeared at 4 degrees 2. In comparison with raw materials, since for acetyl salicylic acid that appeared at 2, and for glycine the most intense peak at 9 degrees 2. For the crystalline product, presented signals that were different from the raw materials by 11, 17, 18, and 25 degrees 2. In addition, this product did not have the characteristic plane 100 of the drug compared to ASA-GLY systems, which may refer to part of the drug's methyl affected by hydrolysis. corroborated by 13C NMR and solid-state crystallinity for the ASA-GLY system. It is observed that in the sample acetyl salicylic acid glycine acetone, H2O, the most intense peak appeared at different degree 2, compared to the raw materials. For the crystalline product, there were signals different from the raw materials, especially at 11-2, which is characteristic of the two products obtained from glycine. Possibly it is a plane that crosses in the ASA-GLY interaction, mainly in the range of 15 to 32. A series of signals different from those of its raw materials and with less intensity are presented, which indicates the presence of a third component. Thermal analysis, differential scanning, calorimetry, DSC analysis showed to what temperature and energy difference or enthalpy changes were brought to. Apply variation of energy or supplied electrical power, MV, that were analyzed with airflow. For the ASA-GLY 1-2 system, the decomposition temperatures for GLY was 247 and recrystallization in 265.5 degrees Celsius. For ASA 138.1 and 147.5 degrees Celsius, and for the crystalline product of 124.5 and 228.9 degrees Celsius. Presented two different curves or ranges to the raw materials, suggesting the formation of a different phase and a different thermal behavior to the drug and conformator in the second system. Presented two different curves or ranges to the raw materials that can be attributed to the fusion processes in the second. To the decomposition temperature, suggested the formation of a different phase or a complex through the interaction of both raw materials. Solid 13 carbon NMR analysis displacements were presented in the crystalline product, which indicated the possible formation of a hydrogen bond between the raw materials, which be reflected in the chemical displacement of C7 NMR of AAS, as well as the hydrolysis of ASA during the 10 minutes milling process, becoming salicylic acid salt, which is why the methyl signal C9 were not presented in the product obtained. The C7 of acetyl salicylic acid that were protected from 172.9 to 172.2, being affected by the environment of the NH2 group and COOH of the amino acid. In the same way, the C1 and C2 of the amino acid were displaced and double signals are presented, which refers to the presence of two glycine molecules, which does not happen in the mixture of raw materials. The C1 from 176.3 to 176.5 and 174.6, and C2 from 43.5 to 43.9 and 42.7 respectively, carrying out a protection, presenting a possible interaction between the carboxylic acid of the drug and the amino group of the amino acid. In this sample, we do not hydrolyze the drug. reflecting the presence of C9-methyl and the C8-carbonyl in the crystalline product, the effect being possible to decrease the milling time from 10 to 5 minutes. Dissolution test. The dissolution profiles were obtained. The release percentage obtained at pH 6.8 is almost double that of pH 1.3 after 1 hour, being less soluble in acidic pH. Similarly, the dissolution is greater in the ASA-GLY system than in ASA-GLY and consequently higher than ASA in both pH medium, demonstrating that the use of UV-vis spectrophotometry is useful for the quantification of drugs present in a medium proposed structure for interaction between SA and GLY, considering the analysis of the presence and displacement of the infrared bands with the presence of a new NH band. The displacements in 13C and NMR, the presence of a single carbonyl, C7, and the disappearance of methyl, C9, and interaction by hydrogen bridge. Represented by the following structure of figure A and the second system ASA-GLY, considering the presence of two corresponding signals for each of the C1 and C2 carbons of the amino acid. The structure of the crystalline molecule is proposed as shown in figure B. Conclusions. The obtained product allows us to appreciate transparent crystalline structures in atrial form. The displacement of a new NH band in FTIR and Raman analysis, a displacement of the carbonyls in 13C and NMR in solid state, shows the different products. The analysis by XRPD indicates different crystalline plans, and the DSC analysis presented the transitions for each materials, demonstrating the difference between the products and the raw materials. In addition, the improvement in solubility is noticeable in the products obtained at both pH